Now I will give you the position x of an object as a function of time, and then we're going to ask ourselves a lot of questions about velocities, accelerations, sort of everything you can think of, everything we have covered, speeds, and I will cover here 4 seconds of time. So this is the time axis in seconds, and we will cover 4 seconds. So let this be 1, 2, 3, 4. And let the object be at position +6. This is my x-axis. This is where the object is actually moving. And this is 3. And here is -3. And this, let's say, is in meters. Let's make a little grid so that it's easier for me to put in the curve. All right. So now comes x as a function of t. At time t equals t seconds, the object is here, and it came from there. And this part is a parabola, and this parabola here is horizontal. It's important. You have to know that. So this is a parabola. And this here is horizontal. So the object goes from +6 to 3, then it goes to -3, then it stays there for 1 second, and then it goes back in 1 second to +6. It's a one-dimensional problem. The motion is only in the x-axis, along the x direction. Let's analyze all these different seconds that occur. Let's first take the first second, during the first second. Since this is a parabola, you know that the acceleration is constant. So I hope you will conclude immediately that a must be a constant. If a is a constant, the position x as a function of time should change as follows: x0 plus v0t plus 1/2 a t squared. I expect you to know this equation. All right, what is the velocity here? The velocity starts out to be 0, and the velocity here is not 0 anymore. If I look at time t equals 1, then I have here x0 was 6. It starts out with velocity 0, that's a given. And I get plus 1/2 times at squared, but this is only 1 second. And so when it is at 3, I have 6 plus 1/2 a times 1 squared, and so you'll find that a equals -6 meters per second squared. So during this first second, the acceleration is -6 meters per second squared. And the velocity v, as a function of time, is the derivative of this one, is v0 plus at. v0 was 0, and so that is -6 times t. So the velocity is changing in a linear fashion. What do I know about the end of the first second? Well, I can say that x is 3. What do I know about the velocity? Well, the velocity is -6 What do I know about A? I don't. I don't know about A. It's true that during this first second, A is minus 6 meters per second squared, but it changes abruptly at this point, so it's ill-defined at this point. In fact, it's actually non-physical. So I really don't know exactly at the end what the acceleration is. Let's now go to the second second, and let's see what happens there. Second second. And first, let's look during, and then we'll look at the situation at the end. During the second second, it is clear, since this is a straight line, that the velocity remains constant, and it remains minus 6 meters per second. That is exactly what it was at this point at the end. You can see it goes 6 meters from plus 3 to minus 3 in 1 second. So the velocity is minus 6 meters per second. The acceleration is therefore 0. You see that the acceleration changes abruptly from minus 6 meters per second squared to 0. So I can't tell you what it is exactly at this moment in time. So that's the situation during the second second. And what is the situation at the end of the second section? Second. At the end, I know that x equals minus 3. What is the velocity? I don't know. Because it changes abruptly here from minus 6 to 0. So I don't know exactly what it is at that point. It's a non-physical thing. It's a very abrupt change. And the acceleration, yeah, that's also a very tricky thing. Because if the velocity is minus 6 on this side of the 2 seconds, and here becomes 0, and if that happens in a split second, there must be a huge acceleration just at that point, which is non-physical. So I would also put a question mark at the A. I don't know what the A is. So we'll go to the third second, this part. Let's first look during the third second. Well, the object isn't going anywhere, it's just sitting there. X remains minus 3. And the velocity is 0, and A is 0. We can agree on that. What is the situation at the end of the third second? That means t equals 3. Well, all I know is that x is minus 3. That's non-negotiable. What the velocity is, I don't know, because it's changing abruptly from 0 to a positive value. So that's ill-defined. And the same is true for the acceleration. There is a sudden change in velocity. That means there must be a huge acceleration. It's unknown, ill-defined, because this curve is, of course, not very physical. Let's now look at the last second, it's the fourth second. First during. Well, it's going from minus 3 to plus 6, and it's a straight line, so the velocity is constant. If the velocity is constant, then you can immediately conclude that A is 0, there's no acceleration. And it goes 9 meters in a time span of 1 second. But it's now plus 9 meters per second. So the object first went from positive values of x to 0 and to negative values for x. During all that time, the velocity was negative by our sign convention, and now the velocity, it goes back to plus 6. The velocity becomes plus 9 meters per second. What is the story at the end of the fourth second? Well, all I can say is that x equals plus 6. I don't know much more. I don't know what the velocity is. Neither do I know what the acceleration is. The plot stops there anyhow. Now I would